Hey everybody, happy Wednesday today. It is day 3 of humans versus bacteria. We're going to transition today away from the Black Plague and talk a little bit about COVID. Um, and then ending with natural selection, which is going to talk about how antibiotic resistant bacteria show up, along with how we get new types of viruses. We'll finish pages 9 through 14 of your notebook. Stop right here and do the attendance task. So looking at there's a video right here that you all have to watch, and then there's 2 articles to choose from. So this video is all about the coronavirus explained, history of it, along with how we treat it. So go ahead, click on that, watch that, and come on back when you're done. Okay, you should write down 1 or 2 things that you learned from that video. Secondly, there's 2 articles. This first one is an interesting one about flattening the curve. It has some kind of interactive pieces. The second article is from Time, more recent, about all the different countries and their responses to the pandemic. So if you're interested in how different countries did, comparing us to other countries, for example, that would be a good one to look into. So either this article about flattening the curve or this article about best global responses to the pandemic. Go ahead and pause, choose one, and read that. And so hopefully between those 2 things, I know you've been hearing a lot about the pandemic and COVID. So, but hopefully they were informative. And so toss down your thoughts here. Okay, the next step is to kind of understand where the new bacteria and where the new viruses come from. And that's all about natural selection. So in your notebook, go ahead to page 10 of this, and we're going to talk through some of this. So I divided these up into 4 understandings. Understanding 1 is that everything in the world has variation, differences. So a variation is any difference in traits. It could be on the outside or it could be internal, and no 2 things are identical. I put some variations. I color here, I put peppers over here. Here's some examples of, although they're purebred, what they have variations. So maybe circle 2 or 3 variations between these 2 purebreds that you recognize. One more example. We got mama pup here and all the baby pups. What are some thoughts on what do you think the father? What are some physical traits that the father had based on the puppies? So I assume you all can identify and understand variations, but where do variations come from? What makes us all look different? And the key is mutation. So DNA, this is what DNA looks like, your information inside of you. It creates proteins. Now these proteins could be eye color protein, hair color protein. And what happens is if you mutate so a mutation is a change in your DNA that can cause a different protein or no protein to be made. So these changes are random. They happen to all of us, and they, if they're beneficial, they could be passed on to offspring. But many are harmful or don't do anything. So there's some examples of human mutations. In fact, we all are probably have some mutations showing in us. We'll talk about a couple here. So this is my first thought is the Homo sapiens, the human species, is thought to have shown up down here in the southeast corner of Africa and then spread throughout the world from there. So the traits that existed here at the start were very different than how we look now. And so every single difference from how we looked at that point is mutations. So we mutated as we spread all over the Earth. One other example of a mutation would be albinos. So we just saw an albino squirrel in our neighborhood. That is a mutation where, if we go back to this picture, the normal gene for coloring of skin and hair, something has changed, a mutation in the gene. So now no protein for color is made, and that's what is with albinos. The last one would be lactose intolerance. So somebody who cannot digest dairy. Again, the normal gene for making that protein is not available. Okay, understanding 3. So we have variation. Mutations make more variations. The third thing is, if it's good, it will survive. And we call a good variation an adaptation. Traits that help an individual survive its environment. If it's inherited, that simply means it's going to be passed on to the kids. So we can see some adaptations in these pictures. This owl, owls are nocturnal. That's a different adaptation, but it's camouflage in there. Camel has the adaptation to survive the harsh environment of the desert. Giraffe has a long neck to reach leaves that are out of reach for most other creatures. Polar bears are designed for the Arctic. Cactuses store water. Peacocks have this amazing display of feathers. All of these are adaptations that help them survive. And they pass those adaptations on to their kids. Here's my in-depth look into polar bears, all the different things that make them perfect for living in the Arctic. Everything from the snout shape and length to their overall structure of their body to minimize heat loss, their feet so that they can walk on the ice, and their skin is black to absorb the heat of the sun. They have a thick layer of fat to insulate them, and there's a zoom in on all of the features of their fur, and then the white fur for camouflage. So we could pick any animal and talk through the adaptations that they have. Polar bears are just special in terms of the extent to which they're specialized. So at this point, if you go to the notebook, there is a link to this article, and it has tons of survival adaptations. So pause and click on the link and just pick 2 of your favorites and then toss them in here. So the final understanding is that the better the adaptations, the more likely they are to survive. Over time, more and more adaptations exist. And we call this fitness, that the longer it lives, the more babies it will have, and the favorability of the traits increase. So here's my example. We have a variation. Some rabbits are faster than others. We have fast, medium, and slow rabbit. They all have babies, so they all can pass on their speed trait to their babies. In comes Mr. Fox, and it needs to eat, so it chases the rabbits. It obviously will get the slowest rabbits first. And if all the slow rabbits are gone, it'll have to start hitting the medium rabbits. It won't have the need to catch the fast rabbits. So overall, the rabbit population will get faster and faster. And in response, if the foxes don't get faster or trickier, then they won't get to eat. So it's back and forth in terms of this natural selection. So let's do some application of this. A famous natural selection experiment is the beaks of the birds on the Galapagos Islands. And so we see the original graph here, and this is looking at the number of the birds with the different size beaks. This is the depth of their beak down here. So you can see before the drought, the average is right around 9.5 is the size, the depth of their beak. After the drought, 2 years later, you can see that it's shifted towards the bigger beak. What would that cause? Or what caused that to happen would be a better question. It got bigger because the seeds got bigger. Small plants died out and only the large plants with large seeds survived, and so only birds with bigger beaks survived. And you can see very few survived. They had 751 birds before the drought, and only 90 after the drought. So a very interesting example of how variation existed. And then in this case, the environment changed and the adaptation needed was the bigger beak bird. They survived and they had babies. And then on a small scale, more of what we're looking at here is how does this relate to bacteria and specifically antibiotic resistance. So antibiotic is the medicine we take to cure an infection. So we assume that there's all these bacteria, and then some of them have the variation of resistance, so it means that they can defend against it. So these orange ones don't get killed by the medicine. So after you take medicine, only the orange ones survive. Well, they have babies, and all of their babies are resistant because they inherit that trait. What's even worse for us is that bacteria can actually just pass on their trait to other bacteria. Humans can't do this. This would be like if I was super fast, I could like give you the special info on how to be super fast. Humans don't work that way, but bacteria do. This is especially concerning in terms of if you have one of these infections, there's sometimes where they can't treat it, and it can be really problematic. Here's another view of this. So we have our bacteria. It reproduces into various variations, different mutations, give them different features on the outside. Now, antibiotics, this is what we're using to represent antibiotics, they go and attach. You can see there's antibiotics fit here, and it fits here, so it's going to kill off these. But the shape of it doesn't fit these guys, so this resistant strain survives. And they have babies, so now if you try the same antibiotic, it's not going to work. And it's considered then resistant to that medicine. We've seen since we've started using a lot of antibiotics, more and more resistance grows in bacteria. So that's kind of the overview of COVID and the overview of how resistance occurs. The last thing, as we talk about natural selection, is a zoom in on malaria, which isn't a huge issue in the US. But there's lots of places in the world that have to deal with malaria, and malaria actually is a good view into how the humans have had this natural selection occurring, as well as the disease itself. So the video is linked on the notes here, okay? And then a 2 to 4 sentence summary about how natural selection is affecting the fight against malaria. And that'll be it for today. If you need anything, let me know. Have a good one.